can hear me, hopefully. I haven't stood on my mic, which is probably something that I would normally do. Right, first things first is we can do a poll, because there are a huge amount of you and there's a huge amount of infrastructure to know in the world. I definitely know probably about 1% of all there is to know at an optimistic perspective of infrastructure stuff. So, if you all fancy filling in a live poll, you can do that, and we'll look at the results as we go in a bit later. So that's dpll.co/1717-5e5. About me, I do stuff and I try and scare everybody awake at the beginning of my sessions with my face. Okay, infrastructure fundamentals. So again, I am not an infrastructure person, but when faced with, we need to build a probability of default model. We have to basically manage the capital of 600 million loans, kind of thing, right? I had to put in all the infrastructure to be able to support R. And that was really hard, because I came from a Microsoft background. So Microsoft BI was all GUIs, and we had sysadmins who took care of everything for us on the infrastructure side. So it was really hard. I had to set up a virtual machine, do all the networking associated with that and being able to connect to it from my machine and things, and other people's machines. Had to learn all of the Linux bits and pieces. Then Apache and firewalls and backups, and it was hell. Infrastructure is really hard, and I still am, things like file permissions and user permissions in databases, I am still terrible at. And I really thank God when I have a DBA who can do role-based access on a database for me. But what I wanted to do was just kind of cover some of the headline concepts for you guys, so that hopefully it's a bit less scary for you. Because like R, it can be quite scary when you first start using it. It has a big learning curve. It's the same with infrastructure tasks. There's a heck of a lot of jargon. Everybody in it already seems to know everything, so they never explain things simply without acronyms. So I just thought I'd kind of cover some of the concepts, not necessarily the details, but the concepts about the things that I think when you're an R person and you might need to find yourself setting up a server, what are the things you need to think about? Okay, so this is my network. This is everything in infrastructure, right? So you have your multiple machines, and they all need to communicate. That's networking. So when they go between machines, when they have to have storage somewhere. So you can't just run everything in memory. Sometimes you've got to save that CSV of data. So you need to be able to talk about storage. And then you need to be able to, have an interface of some sort to communicate with the outside world, have all these management routines, deal with storage, and that's your operating system on which all your programs get run. So this is my very lazy diagram of infrastructure. It's making weird things happen. Okay, so networks. The first thing that you need to think about is access. So like with R, when we think about access, you need to give something a name. You can do lambda functions on the fly, but for the most part, you give things a name. Okay? And ideally, you want your names to be sensible. You can give a machine a name in a few different ways. It has a physical address, called a MAC address, And that is basically a long string of alphanumeric string that denotes your machine. But that isn't a very nice thing to say, and it also has a lot of information that is not necessarily relevant. So then you can give it an IP address, Internet Protocol. It's basically a nice numeric hexadecimal thing which allows machines to talk to each other. And you can have multiple machines behind a single IP when you need to do clustering and things, okay? So you can do load balancing. And then, of course, you have the nicest process of all, when you can use a name. So you can give a device a name. So your laptops probably all have names. In companies, we've had Simpsons, every server named after a Simpsons character. You can do fun things like that. And then, so that gives you the name of the machine or the resource. And then, of course, if you're communicating over the internet, you probably need to say where that machine is. Because that machine, you could have a Marge Simpson server over here and a Marge Simpson server over here in two different companies, and you need to be able to identify which one's which. And that's where a domain name comes in. So this could be Marge at our consortium, and this one could be Marge at Alteryx. So you use domain names to what they call fully qualify the name. So you give it more information to make it more specific. Which, you know, we all appreciate good naming conventions because we're all good at naming stuff sensibly. We adhere to all the conventions, right? We're very good at that. I'm not. And then the other thing is ports. So if everything, when you have your machine and it's got to send data out or receive data, all of that goes out on a port. So that is a physical or a virtual connection that is specific. So the most common one that we use is port 80. That is our internet traffic. And then there is a secure version, which is 443. But if our machine is doing internet connections, database connections, sending emails, doing backups, looking at an authentication system, that's a lot of traffic. And you don't want 5 things sending things out on one port and 5 things trying to listen to that one port. So what we do is we have specific ports for different types of systems. This makes it easier to connect things up and not get miscommunications. And then once you've got things talking to each other, once you've got access, then the most common requirement is to close that down as much as possible. Because you don't actually want the whole world to be able to access your API that you've written, because it's got proprietary code. And you don't want your competitors to just completely chuck values at it and kind of black box get your algorithm. So you need to restrict the access. One of the most common ways of doing that is with firewalls or whitelisting types of activities. So a firewall is something that sits between your system and the outside world and says, I'm only going to allow activity from these servers on these ports, or they have modules. Usually, as an R person, you can usually find somebody else to do a firewall for you. I do not envy you if you have to do a firewall, but what you can do, and I try and do this myself, is never own physical servers. Always do some stuff on the cloud instead. Let somebody else pay for the hard drives and stuff. So you can usually have an easier firewall experience if you go on the cloud. So I use Azure a lot, just because it has a GUI I can get on board with from an infrastructure perspective. It's nice and simple. So I can set up firewalls to say only allow traffic from my specific section of Azure, only allow it from these specific machines, only allow it on these ports. So that can work out quite well instead of having a physical firewall. And then when you're communicating information across these different networks, you need to think about security. If you send your username and password over the internet in plain text, then it's really easy for somebody to get your username and password because it's in plain text. So when you can, you need to use the encrypted channels. So the most common one that you'll use is HTTPS. So that basically makes it hard for anybody to get your communications and intercept them. So you want to do that where possible. And then whitelisting. 10 minutes? Ooh, okay. I'm not going to cover whitelisting. Whitelisting is it's basically just allow specific people and block everybody else. It's better to be specific on inclusion than just hope to God you've got every exclusion right. Okay. Storage. Storage, you need to worry about how data persists. So one of the biggest problems is if you always save it to just your computer, what happens when your computer dies? If you haven't used any sort of mechanism to make your data locally redundant, so storing it across multiple drives in the event of a failure, or if you're not using an offline backup of that data, then it goes goodbye because you haven't persisted it appropriately. Then users. Users are the hardest thing in the world for me. File permissions. So how do you allow access to a file? You have to have somebody who interacts with it. And again, this is where restrictions come in, a role-based access from an enterprise perspective. And any file storage system, and there are lots of different ones, so Windows uses one, Linux has, like 4 or 5 different file systems in common use. And you can make your own if you're feeling suicidal. It's super hard. They all contain metadata. They have indexes that say, this data is stuck on this bit of the hard drive, and here is the identifier for it. So when you're doing storage, when you're persisting data from your models, and you maybe have just files, or you might have a database. You want to keep that data in the event of a problem with your machine, so you need to think about how you can store it. So if you have lots of hard drives on your machine, you can do a process called RAID storage that basically takes slices of your data and distributes it across hard drives in different configurations, so that in the event of something going wrong with one hard drive, the other ones are okay. But I try not to do that because when your machine gets built by the manufacturer, then they probably get all the hard drives out of the same batch of hard drives, which means they're all pretty much exactly the same age, all built under the same conditions. If something's going to go wrong with one, odds are one of the others is going to go wrong quite soon after it. So a lot of the sysadmins that I know have told me this, of you want to have different batches of hard drives. So it's always good if you've changed and cannibalized your machines over time, you're a lot safer that way. Okay, and then the operating system. When you have an operating system, so you set up a Linux server to deploy your own models to, you have to think about authentication. So how are people going to log in to that server to be able to access the code? Now ideally, in a production server, you never actually touch the code. You have Travis CI or RHub or some continuous integration bit that shoves the code onto the server for you, but people still need to log in from time to time. You need jobs that run on a schedule. On Linux, you can use a system called Samba, and you can create users. And then on Windows, it has Active Directory. You can run quite easily Linux with an Active Directory, connected to an Active Directory. There's a package for that, a Linux package for that, and that works quite well if you're setting up Linux in a Microsoft environment, or you need to be able to do the role-based access and sort of enterprise features that keep your data limited to only the people who need to see it. Okay. You've all probably seen that Dropbox was hacked. Yeah, in 2012. People have been sitting on that data, using it for God knows what for 3 years. Passwords are very, very easy to break. Most people reuse passwords, and they use weak passwords because they're easy to remember. One of the nice things about Linux, and you can do this with some of the Windows servers and stuff now, is you don't necessarily have to have a password to have a user who can connect to a machine. You can use an SSH key, so that's basically a long line of encryption gobbledygook, which is kind of a file that gets compared to another file on the machine. It gets decrypted and checked it's right. So that is a good way of limiting access in a safe way, but again, that's more for techies than, your marketing person. You never get a marketing person to use an SSH key. If you can, I want to meet you and I want to hire you because you're awesome. You can sell anything. And then patching. Most vulnerabilities in software and operating systems, they get disclosed fairly rapidly, but they still get exploited years after somebody said, hey, you can brute force logins to this, because people don't update their servers. So it's quite important. On Linux, it's just apt get upgrade. On Windows, it's a bit more complicated, but patching is really important. You need to think, if you're in control of a machine, that you keep all your software up to date. Okay, PowerShell. There are scripting languages for your operating system. PowerShell is pretty nifty. It's basically a function. It's very much a functional programming language, really. It's got a fantastic naming convention. A lot of you probably haven't seen PowerShell, but you can read that script. And especially if you use Magritte, it works really well because you can do the piping of inputs from one thing to another. And it works on Linux as well. So, who uses Bash? Okay. So the rest of you, Bash is a very nice very powerful programming language, really, but it is quite horrible to learn. And it's not necessarily the most clear. So Linux, PowerShell can be a good starting place. In many respects, it's like the difference between dplyr and datatable. I totally use datatable, but dplyr is a better starting place for people with less programming experience. And this is what the same task looks like in Bash. So for me, I would much rather read that than this when I'm not comfortable with infrastructure. And you can also do that on Windows now. Only on Windows 10 at the moment. You can, of course, execute any infrastructure command in R. And I think I'm going to get kicked off. File differences. So Windows isn't case sensitive, and this will trip you up when you are moving files between servers or trying to connect from Linux to Microsoft and vice versa. So try and get into the habit of having naming conventions that are consistent. Windows file permissions inherit from the parent. I use Linux servers in preference to Windows servers, but my God, I hate file permissions on Linux. In Windows, it's nice and simple. You drop a file into a folder, it gets the permissions from the folder. When you drop a file into a folder in Linux, unless you've done a lot of configuration in about 5 different places, it gets your permissions. So files and store and permissions there are where you really need to pay attention. Windows now has a non-GUI server, which is a lot better, works with PowerShell. Docker, you should totally isolate your code from your operating system. Means that you have to worry less about infrastructure. This is a good thing. There is more info on this in the slide deck. Okay. Automate stuff. Everybody who's written an R package has set up a scheduled job, has written a custom script that does a job for them. You can do that with infrastructure, and you totally should, because why do the same thing day in, day out? Key lesson, when you're backing up your code or your data, you're not done. Until you are testing that your backups work, you're not safely backing up your data. Somebody just yesterday was in the news for their data getting wiped out accidentally, and their backups hadn't been working for a year, so they lost a year's worth of data. Data is priceless. You never want to delete it. You never want to let it go. So make sure you are testing any backups. Avoid actual servers when you can. It's great to use virtual machines. That way, if you break anything, you can drop it and start again. Never use sysadmin accounts, SA, and other things. Always put hard passwords and stuff. And this one's just a hard one thing, that if your database is going slow on a Windows server, sometimes it can be just that they turned on file scanning. And I've seen this on Linux as well. With file access, it gets competitive. Okay, so questions during the break. You can get the slides on this link. Bit.ly is case sensitive, so that capital R is important. I'm on Twitter, and because this is just a tiny fraction of infrastructure, you get a bunch of links here to kind of take it from me. So just briefly, I'm going to go to the poll and see how long it takes me to be killed. Will it work? I've broken everything, and I don't know how to use Macs. So, on that note, it's working. Okay, so only a quarter of you were able to get the link and put the effort in. And I think we all want to get more comfortable with Linux. So do check out the Linux links, and I will tweet out the URL which has some useful things, including some Bash interactive coding exercises. Thank you all very much, and questions after the break.